Hello everyone. Good afternoon. I'm Shivam Datta, founder and CEO of AlmaBetter, and I welcome you all to today's Ask Me Anything session. So, as you all know, this is an integral part of our Premium and Pro program that we offer here at AlmaBetter. And every weekend we organize the AMA session where we invite a distinguished member from the data science community to connect with our students. So these sessions are very insightful for data science aspirants, and these are the sessions which help them develop a better understanding of the industry before they become a part of it. So, with that being said, let's welcome our guest for today, Mr. Dipanjan Sarkar. So, Dipanjan is a lead data scientist at Propulsion Academy, Zurich. So Propulsion Academy provides part-time and full-time data science programs to students who are looking to make their careers in the field of technology. So he has been honored with titles like Top 10 Data Scientist in India 2020 and 40 Under 40 Data Scientists 2021. So along with being a lead data scientist, Dipanjan is also a Google developer expert, AI advisor, consultant, and mentor at various esteemed organizations and universities like UC San Diego. So today he is here to share his understandings of the AI/ML world with the young data science enthusiasts. So hi Dipanjan, thank you for taking the time out for this session. It's a pleasure to have you here today.
Yeah, thank you for inviting me and having me here. Definitely glad to be here. Yeah.
Thank you. So as we start with the AMA, so would you like to add anything about your professional background?
Sure, I think you covered a fair bit of it. So, yeah, hi everyone. I've been working in data science for over 8 years now. And yeah, I mean, I did my master's specializing in data science and software engineering because I wanted to not just know concepts, but how to build end-to-end systems. And I have expertise in machine learning, deep learning, computer vision, as well as NLP. I've solved diverse problems in different domains, and I love sharing my knowledge with the community in the form of books, articles, webinars, workshops, as and when I get time. And besides that, yeah, I think you covered pretty much everything else.
Yeah, that's great to know, Dipanjan. So, first of all, congratulations on your recently published book, Text Analytics with Python. So, would you like to talk about your book in brief?
Yeah, I mean, yeah, I think I published it, though it's been a while now.
Mhm.
So basically, I think the first edition was published probably 4 or 5 years back, and the one you just mentioned, that was the Text Analytics with Python second edition. I think it was released probably in 2019. So I would say it's a bit dated now, given that there is so much advancements which have happened in NLP in the last couple of years, especially with deep transfer learning and transformers. But yeah, the main
Right.
inspiration for me to write any of my books is basically to have a set of collected code snippets, resources, and also concepts which have helped me solve problems in the industry. And these books are basically aimed at practitioners who are already working in the industry or trying to get a foot into the industry so that they can basically pick this up and start reusing the concepts and the code and solve their own problems in a relevant field. Like, let's say, my text analytics book, anyone can pick up, go through it quickly, and start leveraging the code, which I've also open sourced on GitHub, and apply it and solve their own problems in NLP. I also wrote a book on transfer learning in Python a while back. The whole concept again is the same: leverage the relevant chapters and solve different problems in transfer learning, in vision, NLP, and so on. So that's basically the whole idea, like, so that people can have a single source from where they can get diverse information and solve their problems instead of searching everywhere around the web. But now, again, like I said, with so many advancements happening so rapidly, I'm not publishing books that frequently because I don't believe in like overcrowding with the same information, right? So that's where I ventured more into articles and webinars and workshops where at least I can show the latest trends and people can stay up to date without, let's say, spending 1 year on writing a book and then there's already new information coming out. So, yeah.
Yep. Yep. I guess that makes sense. Books kind of become redundant with time. So better to go with short articles and webinars which cover the latest technologies. So I urge our students to follow Dipanjan on GitHub and other uh, portals wherein you can also use some of the open source code that Dipanjan has curated. Okay, so as more and more businesses are deploying data science capabilities to extract insights from large amounts of data, the impact generated stands unparalleled, right? So, Dipanjan, could you talk us through some of the interesting problem statements that you have worked on as a data scientist, and also the impact of such projects, the impact that such projects have had on your company?
Yeah, maybe I will take a few diverse examples. So, one of the most important things probably is in any company, there is infrastructure, key infrastructure, which runs the company day in and day out. Like, let's take this webinar, for instance, which is happening and being streamed, let's say, via Zoom or YouTube. And actually, it's running thanks to a data center back in Google or in Zoom. So, what if that data center goes down? Everything gets affected. So, that is where we solve these kind of problems where by looking at workloads over time, can we predict when a key infrastructure component can fail? So that is where principles like anomaly detection or even predictive analytics, like early prediction of failures, so preventive maintenance, you can think of it in that way, is the whole idea where based on sensor data, based on telemetry data, based on usage data in the devices, can we feed it into a model to predict patterns where we can find out that, okay, maybe the device is going to fail about just now, or maybe a bit into the future, which is more beneficial so that the operations team can do the necessary work and create a backup or keep it running by fixing it in time. So that was one interesting problem where we leveraged statistical models also for anomaly detection, time series models, as well as we looked at interesting deep learning based models to model the whole time series and predict into the future. Another problem was in cybersecurity, where I wouldn't say hardcore cybersecurity, but in the open source ecosystem, where we looked at a lot of open source dependencies in our enterprise software, and we tried to predict if any of them might have vulnerabilities, which is okay if you're doing, let's say, your own project, right? Like a university project or a bootcamp project or something. But if you're working in the enterprise and some of the libraries you're using might be, let's say, having these security issues, that can be a big problem for the enterprise itself. They may lose face if they are selling that product to customers. So that is where we applied a natural language processing coupled with deep learning to figure out in case any of these open source dependencies being used in the product might have vulnerabilities. And other than that, we have solved other problems also, like a lot of things in semiconductor industry in terms of trying to predict if there are defects in the overall manufacturing process in terms of the products being manufactured, or in case there are any gaps in the yield at places. And then other problems related to natural language processing, like standard ID problems where you have support tickets being filed. So can you predict which queue they might go into, or can you predict the priority of how soon they can be resolved? And even self-help service systems where you take in all the internal data of a company and build a searchable index out of it. It's like building your own custom search engine by leveraging principles of NLP, information retrieval, ranking, and so on, so that someone can just search for their problem and get a self-help article and basically start using it out of the box. And that helps by them not creating a ticket, and in turn that ticket taking time, basically manual effort for people to close. So in that way, time, productivity is good, and cost is also saved. So yeah, I think these are some of the diverse problems I've solved
Right.
in the last few years. Yeah.
Very interesting problems, I must say. So because you have had a good experience working as a data scientist and your role has now evolved to a leadership position, so could you tell us a little bit about the approach that data science teams undertake while they look at a business problem?
Sure. So this will vary a lot also based on the nature of the how the data science team is structured. Like sometimes your data science team model might be like a center of excellence model or a horizontal model, which means that you are medium to large size data science team and you cater to different verticals or business units in a company, like let's say we are a data science team, we will solve problems by working with the HR team, with the finance, sales and marketing, product teams, and so on. And there could be a model where, let's say, there are individual data science teams in each business unit, and sometimes there could be both. So in that way, it depends, but the overall structure is similar in terms of the engagement, where usually you will have some kind of a project manager or a product manager or a program manager, depending on the level of engagement it is going to be. That are you adding a new feature into a product, or are you starting off a new proof of concept or a project? And you will also usually have some lead data scientists who will be involved in those initial discussions. And the workflow is very similar to the industry standard, which is the CRISP DM model, cross industry standard process for data mining. So you usually start with the business understanding phase, where we try to figure out what is the business problem which, let's say, the client or the team or the business unit you are working with wants to solve. And that problem can sometimes be vague, because in the industry, no one will come to you with a very clear-cut problem, usually saying that, okay, take this data and build a classification model. They might have a very vague or a business-focused problem that, okay, we want to increase the user engagement by 10%. So then it's your job as the lead data scientist to also work with other data scientists, like senior or associate or entry-level data scientists in your team, brainstorm together with the whole team and figure out how do you translate that business problem into a data science problem, because not every business problem requires machine learning or advanced analytics. And that is something I think companies have realized over time. Some of them are still realizing it, because a lot of them may want to throw machine learning at every problem, but that's the wrong thing to do. Only if it's relevant, then only you go for advanced analytics. And once we figure it out, we will need some data understanding. And then there'll be a back and forth where you need to decide on at least some high level success criteria of the project, and what are the key goals, and how does the data science goals tie up to the business goals, because the value which you get out of the project is what matters, not the advanced models which you build and so on. And then once those things are being refined, you slowly head into the data cleaning and then your modeling, evaluation, and basically you loop through those cycles again and again till you reach a satisfactory model. And if the business team is happy with it, you go ahead and deploy it if it's a predictive model. If it's just insights, you maybe build a report or a dashboard or a presentation and you show it. And if it's something predictive or real time or near real time, then you will head into the engineering phase where you deploy the model, set it up for monitoring, maybe future retraining, and so on. That's the typical process followed for most projects. Yeah.
Right. That's pretty nicely put. I guess the basic steps of approaching any data science problem or any business problem remains the same. Although you might see various constructs in terms of how the data science teams are organized in an organization, depending on at what maturity level the organization is in terms of adopting AI. So, Dipanjan, you have worked on certain AI models to deal with problems that arise in the security domain. So, could you tell us about that? So, like, what was the problem that you and your team were trying to solve, and to what extent were you able to achieve the intended results?
Yeah, so I probably presented it in one of the conferences probably a year or two back. It was a pretty successful project. It was very challenging also. So this is the problem I was briefly talking about earlier, where the whole point is it was a problem which is also integrated directly into product development. So it was interesting. So this is where we have these products, just like Kubernetes and so on, which is where you scale your applications or you can scale your machine learning models. And these frameworks by themselves are dependent on probably 300, well, 150 to 300 dependencies. Now, a dependency is just like a library. Like, let's say if you're doing machine learning, TensorFlow or scikit-learn could be a dependency. Now, all these dependencies are open source because the whole aspect is an open source product. So relying on open source packages can be good because they have been an active developer community. They are doing a lot of work. So you can just reuse these packages, but it can also be bad in a way that the developers who are building these packages, obviously they want to push out new features. They don't care about um, always sitting and evaluating security, because often these packages are not built by, let's say, a huge company, right? They are built by a small team of developers often. So that is where, if they only focus on security, then the package itself will not mature. So that is where sometimes there could be vulnerabilities in any of these packages. And actually, if you check the National Vulnerability Database, which is maintained by the US government, you'll probably find a lot of vulnerabilities on most libraries you have used. That there are vulnerabilities which have been seen in TensorFlow, again, speaking in machine learning context, but there are a lot of vulnerabilities which are found in packages over time in different ecosystems like Node.js, basically JavaScript, then the whole Maven ecosystem, that's your Java, and then Python ecosystem, and also Golang, which is the core language for building all these libraries which power Kubernetes and the relevant products. So our task was basically, can you figure out if there is going to be a vulnerability in any of the underlying transitive dependencies which power this scalable product based on Kubernetes? And that is where we saw that NVD is fine, the National Vulnerability Database is fine, but the whole idea again is that the vulnerability has already been found by them. So we needed to basically find out if there is going to be a vulnerability, or someone is talking about finding something, but it hasn't been released officially, that, okay, there is a security issue in this library or this dependency. So the best place for finding this information was public data, because if you're working with an open source ecosystem, then everything is talked about in public forums, in GitHub issues, GitHub commits, and maybe some comments and so on. And that is where we leverage this open source BigQuery database, which consists of all GitHub commits, pull requests, issues. We also looked at security forums, bug forums, where they file these kind of issues or they talk about it. And we basically leveraged some kind of APIs to pull in this data and store it. And we had around 2 to 3 years worth of historical data, where we were able to thankfully label this data using some NLP techniques of what could be a vulnerability issue, right, a serious security issue, and what is maybe a security feature, because sometimes they will just talk about, okay, pushing this new security patch. So that is not a vulnerability issue. And what is not related to security. And then we basically tried out different models, starting with simple classical NLP, and then we dived into deep learning models like LSTMs or bidirectional LSTMs. And then finally, we explored transformers like BERT. And it was really nice to see that these transformer models do live up to their hype, because they gave us a pretty good precision as well as recall rate. Probably, I would say around 70 to 75% precision, which means anytime we were predicting there is a vulnerability, we were correct close to 75% of the time. And that is what it is, right? It's very challenging, because you can imagine the level of imbalance between a serious security issue versus a non-security issue is probably like a ratio of 1:200,000 or something, because it's not like everything is a security issue. And in that way, I think we basically integrated a full pipeline around this to predict issues in case something is flagged probably every other day, and send it to our internal security team, who audited it and told us if there are any false positives, because there will be obviously some false positives, and then retraining the model every week or every 2 weeks, and continue this process ongoing, so that in case there are any potential red flags of dependencies having security issues, our security team is probably one of the initial ones to know about it, and then they can reach out to the relevant packages which may have those issues. So yeah, that's one of the major problems which we had solved.
Right. I guess this is a pretty interesting project because of the kind of impact that it has, right? So, as far as I know, these type of work is being done in the industry, but uh, it is more or less manual in nature. So, whenever you are, pushing or shipping out your product, you do a whole lot of checks and balances to figure out the vulnerabilities manually, right? And maybe some rule-based systems here and there, but to detect them all automatically is kind of a challenging task, because of the nature of the no the kind of unstructured problem it is, right? So it brings a lot of challenges, right? So I guess the impact
Absolutely.
is huge of these, right? So let's take a few questions from the students. So Drishtanta has asked one question over LinkedIn. So what does it take to be the top 10 data scientists in India? And is it the achievements in research or in applying data science in respective domain or industry?
So it depends on who is giving you that award. Usually there are some organizations who do this extensive research across the community and find out who are the people who are contributing in data science. So what they usually check is industry exposure and experience in terms of how long they have been working, what kind of problems they have been solving, what is their exposure like, what kind of domains they have been working in. Obviously, if you have publications or let's say you have written books or papers and so on, they will obviously check that. And also things like community involvement. What are you doing for the community? If it's in India, obviously they will check what are you doing in India? Are you helping people out through some forums? Are you organizing any kind of initiatives like thanks to programs like the Google Developer Expert Program via Google, I get that platform where I have helped out a lot of people in machine learning to upskill as well as do their own things in terms of be it projects or it's like they call it, right? The trainer program where they are training other people to understand machine learning and apply it in maybe their work or let's say in their personal projects and so on. So basically these things in terms of your personal achievements, how long you've been working, what kind of work you've been doing, what kind of publications maybe you have done, what kind of work you have done for the community. And these are all probably factored into account. And then they rank it per year. I guess they try to keep the names different per year. In that way, more people can come into the limelight and more people can know about them, they can engage with them, and in that way they can continue doing more for the community.
Right. And I guess, if we keep the awards aside, these are some things which every data scientist should at least try to do, right? So it what makes you a wholesome person and not just a techie, right? So, these are some of the things that you should be actively doing. And for our students, you should be actively looking to do these stuff when you get into the industry, right? So
Right, right.
I have
Agreed.
Yep. So I have one more question. So from Rohan. So how much is the latest research utilized in the industry implementations? Is his
Yes,
question.
I think this is a very good question. So here's the thing, honest opinion, researchers don't care about the industry. If you look at pure research, what they care about is what is the current model landscape or technique landscape out there? What kind of innovative aspects can I put in to get a better model or get a more efficient model or get a high performing model? Because that is what research is, right? Can I innovate a new model completely or a new architecture completely? Now, what is the relevance in the industry? It depends. Some things will be widespread use depending on whether they are scalable, whether they are easily adaptable, and whether they are easy to deploy. Like let's take convolution neural networks. I think they caught the industry by storm. Now it's probably being used almost everywhere. Models like ResNet, residual networks, again, got pretty hyped up, easy to use, deploy, gives a good performance. Now let's take another new invention which came a while back, capsule networks. I think Hinton himself released it and said CNNs are not great. Capsule networks will cover and fix those flaws. But the model is not as fast as CNNs, and hence it's not used as widespread in the industry as, let's say, CNNs, right? We are still using CNNs almost everywhere. We still see new CNN models coming out. So that's one example where, let's say, research sadly didn't work out, and one example like ResNets and CNNs where it did work out. Another recent example, transformers. I would say it's a mixed opinion because transformers are so heavy computationally that realistically most companies can't use them or fine tune them. But we are slowly seeing more efficient transformers like Distilbert, Albert, and so on, which have a lighter memory footprint. And thanks to them being pre-trained, you can fine-tune them with even less data and get really good performance. So I think transformers have revolutionized NLP, and I'm pretty sure we will see even better things to come. So it's basically a mixed bag. Sometimes research will translate directly into the industry and have a lot of benefits, like Transformers CNN. Sometimes it will not work out because the models are conceptually great. Maybe they work great on toy data sets, but they will not scale for industry problems.
Right. So basically depends on use case to use case, and some research might be very well adapted by the industry, but some might not because of certain uh, flaws. Right. So yep. So I want to take one more question from
Yeah.
Karthik. So this is a generic question, right? So how do you deal with situations where you stop getting ideas for a project?
So for a project, if you stop getting ideas, the best way is to not think about the project for continuously for a while, take a break,
Yep.
sleep on it, come back to it. And sometimes it does help. I have seen it myself when I'm working too much into a problem. You can sometimes develop tunnel vision. So take a break, go online, read up about maybe similar problems. What are other companies doing? There are tons of company blogs out there. There is a ton of resources out there. You can learn a lot even from Kaggle competition pages where people are talking about how they have solved problems which may be relevant to your problem. That's one thing. Second thing, don't hesitate to ask other people. Like personally, myself, I don't still consider myself an expert in data science or whatever. I mean, yes, I have learned a lot, but it's an ongoing process. You have to keep yourself updated. You have to keep learning, and you shouldn't hesitate to ask other people for ideas and openly talk about this is a problem. What do you think about it? And in that way, if you have a collaborative environment at work or even in your personal network, sometimes you can get really nice answers. And that's where the network helps, your colleagues help. So yeah, I think that those are the key things to keep in mind.
Right. I guess that helps. Right. So we all know that there exists a disconnect between affordable education and rewarding jobs in our country. Right. So private institutes charge students a whole lot of money upfront for their courses, programs, and students do not even land a good job. Right. So this way they end up with huge amounts of debt at the very start of their career. So what are your thoughts on skill schools like AlmaBetter that provide risk-free job-oriented learning with guaranteed placement to students? Here, the students pay for the tuition fee only after they start generating income for themselves.
Yeah, I think I'm very glad to see these initiatives happening finally in India because, like, since I have been mentoring and creating programs or even instructing at a global level, usually I had seen a lot of this more in the US, where they have some of these, you can say, boot camps or organizations where typically they have this thing called pay once you start earning, or like a deferred tuition and so on, right? Where you may have to pay a small upfront fee, or sometimes you don't have to pay at all, maybe. But it's like, okay, once you get a job, then you pay a part of your salary based on the fixed rate, and which will amount to, let's say, the cost of the program over time. And I think this basically is great to see that it is happening now in India, like you mentioned, because this shows that we have these organizations who are ready to invest in the students, and they are ready to invest in the success of the students, right? Because the whole point here is if the student gets a job, then only they will start getting paid over time, right? And in that way, it shows that they are really invested in the progress of the student and the hireability of the student over time once they gain the relevant skills, and then they can go out in the market. So I think these kind of programs are pretty good because they will help people who may not be so financially well off, which can always happen, but they can be extremely talented because we have seen a lot of such people over time. So in this way, they are not like losing out on the opportunity to gain all these skills, right? And gain it at an affordable rate where, okay, once they get a nice job, they start paying back, which is okay then because they are getting a nice salary and they are basically working a job. So in that way, I think these are probably the tools and the approaches which is going to continue helping people over time in upskilling and getting better. Because yes, universities degrees, I will still say, is definitely relevant. It's not like it's going out of fashion or something very soon, but these are ways in which you can really learn the key skills to be job relevant and industry relevant, and not miss out on opportunities. So I'm glad to hear these initiatives happening in India. Yeah.
Right. So I guess we are approaching the end of the session, and I would just like to put one more question, Dipanjan. So you have been actively involved in mentoring people who want to enter or are currently working in the data science field. So as a mentor, what would you like to advise the students who are attending this session before they venture into the field of data science?
Yeah, so I would say that yes, do keep a pulse on what is happening around you. You can listen to influencers, you can listen to webinars, and you can read about stuff online, but don't end up emulating them completely, thinking that that is what I should do mechanically. You have an intuition, you will build up some things over time. Go with what you feel is good for you, go with your intuition. Of course, make an informed decision by talking to people around you, but like, don't go about it blindly. That is one thing which is very important, because I have seen people who take a lot of things from around them, but then they make a decision based on what they think is good for them. So that's the main thing. Don't think that you can't make the decision yourself, because you are gaining the skills over time and you have the capability to do what is right for you. So that is one very important thing I want to say. The next thing I would like to say is, uh, you will read a lot of articles or opinions like, should you be a generalist, should you be a specialist? Some people will say you shouldn't do this, you should do this. I would say explore different things, like, let's say, explore machine learning, explore deep learning, NLP, computer vision. You don't need to become a specialist in everything, but explore it, because unless you do it, you will not know what you really like. And that is one very important thing. Don't just go by what other people say. Explore it and figure out. Sometimes you may see that, okay, you do like computer vision, and then you can specialize in it. And there are many industries, semiconductors, healthcare, so many places where it's being used. So explore things, don't hesitate to do things just because you read stuff online. And these are important things, because we are seeing a lot of information flowing in online every day. So I think these are some general things which you should keep in mind. And other than that, I think keep doing the things which you should be doing, like learning and building your foundations of statistics, machine learning. Don't let it be always conceptual, but focus on the hands-on aspects of how is this being applied in different problems. Pick up data sets from open sources like Google datasets or Kaggle. Solve some problems. You don't have to participate in competitive ML, but you can just build end-to-end projects, build up your portfolio, and that will showcase your skills. It will showcase that you can solve diverse problems, and it will continue helping you not just to get a job, but even once you are inside a company and working day in and day out.
Yep, that's some great piece of advice, Dipanjan. So with this, we have now reached the end of the session. I would like to thank you, Dipanjan, for joining us today. Hopefully, the students listening to this session got to learn a lot of new things. So one last request to the audience: you can follow or connect with Dipanjan on LinkedIn, and many of the questions which we could not cover, probably will cater to them over LinkedIn. So again, it was lovely to have you here today, Dipanjan. Thank you so much for your time.
Yeah, thanks for having me, and thanks everyone for attending this on a weekend. And yeah, really appreciate it.
Thank you, Dipanjan.